I'll be honest up front. I've got a lot of slides, so I'm probably going to go through some of these pretty quick. There's a lot of material in here because WSII is fairly complicated. I would like to make sure that the two other cohorts on this project are acknowledged as well. Mike Muccilli, who's an intern here, has been involved in the last couple of years. And really, Nathan Foster was the huge driver behind this. He's out in Las Vegas now. He's left Eastern Region, but he is still involved, and we still stay in contact. You know, I kind of come up with the crazy ideas, and he looks at me funny and says, "Oh, I think I can make it work." So that's how we've kind of evolved this over the last few years. So just what I want to hit today or this morning here. Just a quick background of what some of our Winter Weather Impact Index projects have been, and then why we're doing this and how we do it, and some examples. So, I mean, there's a lot of stuff out there. This was something that was floating around on the internet, I think, last winter. You know, here's somebody's idea of how much snow it takes to close school. So, you know, the idea of trying to depict impacts and in map-based form is out there all over the place. So in the winter storm arena, Cosin and Louis, back in 10 years ago, they came up with the Nessus index. So hopefully Louis is not on the line because I don't think I'll be able to answer all the questions about it. But in summation, it was a Northeast U.S. oriented way of looking at the overall impact of a snowstorm, but it was just based on population. The amount of snowfall at certain levels over how many people it was affected. So you get 6 inches or 10 inches of snow in New York City and Boston. That's a huge storm. That same storm 200 miles north across Vermont and New Hampshire doesn't rate on their scale. So you know, that's what they had, and it's an after-the-fact deal. The NCDC has taken Nessus and turned it into the Regional Snow Index. So they've calculated sub-regional climatology basis, and after each snowstorm, they create the information of how much snow fell where, related to population, and do it that way. I look back on the RSI, and I think everyone remembers the big story from last winter, the Atlanta winter weather event where everyone got trapped on the roads trying to get out and all that. That showed up as a Category 1 on their RSI, just to put that in there. I'll touch upon that a little bit later in the talk. The other index, at least that I'm aware of, is the local winter storm scale. I believe it was Brian Cerruti started this about 4 years ago, and it was an attempt to correlate more than just snow amount to impacts, but looked at other elements of a winter storm. And so you calibrate that going through a process of what's called the Rooney Disruption Index. And I'll be honest, I'm not really up to speed on all of that. I've talked to Joe Della Carpini at Taunton. He was one of the offices where they were trying to implement this within GFE. So that the process is you go through your history for the ASOS sites, pull out all the information, the METARs for winter storms, and then calibrate that back to impacts that you pull from news media and all that. It's a very intensive process to do, and as far as I know, nobody ended up actually being able to finish the whole project within GFE. And it was only for a particular point, really, only where you had the data. So this was one of his tables in a presentation, just to show you real quick some of the things that they were trying to look at. So it was looking at wind speed, wind gust, the total amount of snow, some ice, and how low the visibility was, because that's what you get from the METAR data. And the higher the winds, the more the snow, the more the ice, the higher the factor was. And so he actually has a 0 through 6 scale, so it's 7 categories, which is kind of odd, you know, thinking of, you know, hurricanes and all that. We're more in like the 0 to 5 or 1 to 5 sort of thing, but that's what they had. So our WSII, the Winter Storm Impact Index, so, you know, why are we, you know, why did we even try? Why did we, how did this all come about? we're, I guess, a big proponent here of using our own data. It's a strange concept sometimes in the Weather Service, but we were looking at NDFD. We were doing other things with GIS already, and it's like, well, we got all this information. Let's talk through and what can we do with it? What makes a winter storm? And since doing it in GIS, you can pull in other information other than just weather. And so we've got some other data layers in there, and I'll hit upon that in a second. Also, the whole Winter Storm Impact Index, the whole point, or one of the big points of it is trying to get at what is the risk of the impact if really no preparations are made. And that fits squarely into what the Weather Service is all about now, the IDSS, the I for impact. I think every forecaster at every office also knows that, we had a 6-inch snowstorm last week, we got another 6-inch snowstorm this week, and it's a totally different beast. Yet in our, the way we go about operations, if 6 inches is our winter storm criteria, well, that's a warning, even though each storm is individual. So we're trying to get beyond those words of watch, warning, and advisory, which in themselves are already confusing. And at the national level, there's the hazard simplification project going on, and that's really trying to move and evolve beyond using those words that we've used for decades and people still really don't understand. And lastly, we were looking for something fun to do. I don't know, I like this sort of stuff, playing with the data, so it was a good fun challenge. Can we put something together? So what the WSII can bring is, we think giving a better depiction and maybe improved communication of what the potential impact could be due to winter storms. And for more than just how much snow is going to fall. It's a whole lot more about the winter storm. And this, if this became something that the Weather Service actually was doing and producing, it allows the forecaster to forecast on the meteorology and, let the algorithms kind of do what they need to do, and you get the answer for where the impacts could be. It's map-based, so, I don't know, a picture is worth 1,000 words, and because it's using the NDFD data, it's got that much improved granularity at levels below or beyond just a zone-based watch, warning, advisory thing that we do. And since we're pulling forecast data, ultimately this could also be done in a temporal thing, so you could see how the index would evolve over time. We're not doing that right now, but that could be. Weaknesses, I'll be honest, when we came up with each of these components, we sat down and we just bounced ideas off of it. What through our experiences have made a winter storm a bad winter storm versus not so bad winter storm. So it was a lot of discussion, a lot of subjectivity that we worked into to come up with a more objective table. The WSII is totally based on NDFD, so it's our official forecast. And if we forecast 1 inch and 12 inches fall, well, the WSII isn't going to show that 12 inches and a big storm is going to happen. It's going to run off the 1 inch. So it's as good as our forecast. It's not meant to also be anything in specific for impacts. So that slide I showed a few minutes ago about how much snow does it take to close schools, we're not really getting at that. We're not getting at when do states have to close the throughways or freeways. It's more of a bigger, higher level, just in general, what's the disruption on society? How much preparation are they going to need? How much does it change their way of life, and how long will it take to recover? We're trying to capture that. The WSII doesn't have any knowledge of what's already on the ground, or if you've got two separate events back to back, it can't handle anything like that right now. And it's in the end, it's just a total combined effect. So if it's a storm where there's 80-mile-an-hour winds and blowing and drifting is a huge problem, but the snow amount isn't a big deal, well, you might get that there's this bad storm, but you don't know exactly what the driving factor is, and that may be important for some decision makers, as I put on there. The decisions you have to make versus of dealing with blowing snow or ice accumulation are completely different, even though you might end up with the same number of level 6 storms. So it is what it is. It's got some good things and bad things, or weaknesses rather. So the different components that we're doing, we're taking from NDFD the snow amount information, QPF, wind gusts, and ice accumulation. We then run the calculations to compute snow-liquid ratio, a 36-hour total snowfall. We're just doing 36 hours at this time. We can calculate a snowfall rate, how much snow fell over 6 hours, so you can get an average snowfall rate, and total ice accumulation. So that's from the forecast. From the non-forecast aspect, we're looking at land use type. Is it tree covered? Is it an urban area? How much snow normally falls in the area? So climatology, and that was a big thing to just even get that. You thought that would have existed a long time ago, and it really didn't. So we've now got a good climatology, and we want to do more stuff with population as well. Don't have that in there yet, but we have some ideas. So we take all of the NDFD data and all of these extra data sets and running a bunch of calculations on the data through GIS. So we're comparing the non-forecast data, the land use type, for example. So we're looking at, if we're trying to do something with blowing snow, well, it's going to be more blowing snow where there's no trees, and so we can factor in the trees versus the non-tree area. Climatology, that gives us the normalization of 2 inches of snow in Atlanta is not 2 inches in Pittsburgh. There's a totally different reaction because of just climatology. And again, population, we want to focus in or have some aspect of the more populated areas are going to be a little more impacted given the same conditions as a more rural area. So the WSII is made up of several subcomponents. So we're looking at the snowfall rate, the snow load, a snow amount, the amount of blowing snow, and the Sperry Pilts ice accumulation. We're not looking at timing because we're using 6-hour NDFD grids. We don't have the hourly resolution in NDFD. We can't say, all right, this snow is happening at rush hour. We don't have that. We're not looking at temperatures. If we've got a winter storm with really cold temperatures at the same time, we don't have anything like that. But so it doesn't cover everything under the sun, but it still gets a number of important components of the storm. So the individual components, one of them is the snow load, and this is trying to look at that wet snow that accumulates on the trees and power lines. It could also be that heart attack snow, really hard to shovel. Right now, we only have that going from spring through the summer, if there was any snowstorms, into the fall, because we're just looking at it with the assumption that the deciduous trees have some leaves on them. There's been some recent events here in Vermont and New Hampshire in the last few weeks that we had a number of pretty significant impacts with utilities because of wet snow, even though there's no leaves on the trees. So we may need to look at that. And then we look at, is it, the urban areas or the Great Plains. A heavy wet snow that lands on grass is not going to do as much as heavy wet snow that lands on maple trees. So down here at the bottom, what we do, a lot of our components, as I mentioned earlier, are subjective in nature. So we've defined the various snow liquid ratio ranges, and we've assigned it a category. So 1 is nothing much, 10 is weighted more. So as the snow liquid ratio gets lower, becomes a wetter snow, the category that we assign it becomes higher. And these breakoffs, that's the subjective part. So anyway, we calculate that, we multiply that by the total amount of snow over 36 hours, and so you get some value, and then we, again, look at the category, or the number that you get, and compare that to the category. So, for example, if we've got 4 inches of snow that is forecast to be a 9-to-1 ratio, so it gets you category 8, which times 4 inches of snow, 8 times 4 is 32. 32 falls into the snow load category of 3. and at that point, if it's over the mountains of the northern Rockies or whatever, I think we take off half of the 32 because it's, there's no trees. So the final answer in that case would be like a 16 and, snow load of 1. We also are looking at snowfall rates and the amount, and these we normalize on climatology. So what we did last year was we had a really kind of a poor climatology. It was only in rough bands that we knew it was 0 to 10 inches, 10 to 15, I think it was 15 to 18 inches, 18 to 42 inches, and 42 to 80 or so. It was really kind of weird. But that's what we were working with, and we tried to assign certain categories and factors depending on what the climatology was. So we didn't know if it was 20 inches or 21 inches at any location. It was just 18 to 42. So with this year, now we have the actual specific, it's 18.1, 18.2 at this grid point, et cetera. So we tried to map our process last year with an equation, and you get this exponential factor. So what this purple line shows is as you get closer towards 0 as a normal annual snowfall, the amount of equivalency, I guess, increases. So down here at the bottom, I think it's the best way to explain it. So we'll take St. Louis. They normally have 22 inches of snow a year. And through our little trial and error and this equation, you plug that in and you get a factor of 1.7. Where Albany, which has a, so then if St. Louis has 6 inches of snow, you multiply it by that factor, and 6 inches in St. Louis is equivalent to 10.1 inches of normalized snow for, wherever that might be, this baseline. For Albany, because the average snowfall is higher, 59 inches, the normalization factor is close to 1. So a 6-inch forecast is roughly 6 inches in our scheme. So you can see just from the climatology, St. Louis, with the same 6 inches of snow, the equivalent is like basically 10 inches in Albany. We do the same thing with snowfall rate. So the areas that get less snow, any little bit of snow at a small rate of snow increase or accumulation is normalized to a much higher value. So Atlanta, 2 inches on average. If they get 1 inch of snow, 1 inch of snow in an hour, that's equivalent to a 2.1 normalized rate in our scheme. Coming up to Connecticut, 1 inch in Hartford is roughly a half an inch per hour in the normalized rate. So we're trying to account for the climatology. So we take that normalization factor and we plug it in, or times the snowfall, and then plug it into what the categories are. So if we are looking at a 1 inch, 1.1 inches of snow an hour normalized rate, that we call a snow rate category of 7. And similarly with snowfall totals, we say anything over 24, that just maxes out our scale. But this is how we've broken it down. So you take that forecast information, the actual raw data, you normalize it to climatology. We look at what category it falls in, and then we look at the 2, and whichever's higher we will use as the component of the snow amount slash snow rate. So if we had a forecast of 7 inches and a snow rate of 1.3, 7 inches is a category 5 on our table. 1.3 inches an hour is a category 6. The answer would be a category 6 for the snow rate and snow amount as that subcomponent. So here's the snowfall climatology that we're using that we got from NCDC a couple of months ago, and so it looks pretty good shape. Things range from 0 to over 800 inches in the northern Rockies. So to show you how these algorithms would work, so if we had 1 inch of snow forecast, and then we ran it through our normalization, the snow amount would calculate to this value, so on a 1 to 10 scale. So 1 inch of snow in Florida, that maxes out our scale. That we would consider crippling. In the deep south, it reaches a category 8, which is on the major side. As you see, as you go farther north, where there's normally more snow, the normalized snow amount or the category will decrease. If we go to 3 inches of snow, for us up here in Vermont, that's still a category 1, maybe a category 2 on the snow amount. It's no big deal because we get a lot of snow. You know, I don't know if there's anyone from the Carolinas, but on ours right now, that would max out. 3 inches of snow would get you into the 10. You know, we have to, these algorithms and the equation, we can still look at these, and this is what we want to evaluate and see how good we are. But the point being that, you know, as you go farther south, it doesn't take as much snow to really cause a big problem. 6 inches, this is our local warning threshold up here, and on our scale, we've got it 5 to 6 here in Vermont. As you go farther south, you get to the top end of the scale. A 12-inch snowfall, if it was 12 inches all over the country, it'd be a 9 or a 10 on our WSII. Similarly, for the snowfall rates, again, this is taking if a 1/4 of an inch of snow an hour was falling, what category would you end up based upon climatology? So up here in the northern tier, it's, you know, no big deal, and it becomes a moderate deal down in the south. You go up to a 1/2 an inch of snow an hour, and in our little equation will get you a pretty moderate to low-end major situation down south, and still fairly low up north. 1 inch an hour, you can see we're getting pretty high on the scale down south, and 2 inches an hour, you know, by our little calibration, it's big in most areas except where lots of snow falls. So that's another component. Yet another component we're looking at is blowing snow, and what we do with that is we take the wind gust information, we look at what the maximum wind gust is, and we have a category for that as well, and this is down in here. We found some studies that were done in the Canadian Plains and Wisconsin, you know, really suggested that you get over 25 or 30 knots, and things start to really become problems in the open areas. So, you know, getting a category 5 is you know, pushing over 25 knots for our wind gust. So we get the wind gust category, and we've already computed snowfall ratio. We know how much snow we have, and then we put that. We have a little land use factor as well, and I'll touch upon that in a moment, to normalize things so that if you've got open plains, you're going to get more blowing snow at the same wind speed than if you're trying to blow that snow through a bunch of trees. So you just do these calculations. Again, we subjectively came up with it, but trying to account for everything that we thought was part of blowing snow. And we compute it for every 6 hours, and then we have a cumulative factor on the blowing snow, because over time, if you keep blowing the snow and you keep adding more snow falls, it becomes a cumulative problem. So we take our current snow and then whatever it was for 6 hours previous and 6 hours previous to that, we look at that and see which is better. So here were the examples I have in here real quick. So pick 34-mile-an-hour winds. You're in the Central Plains. It's open. You have dry snow, 18-to-1 snow-liquid ratio, and you have 4 inches of snow in a 6-hour time period. You're just multiplying the 6, which is the category for 34 knots or 34-mile-an-hour winds, times 18-to-1, times 4 inches of snow, times our factor, which we leave at a 1, and you get a 432 on this, which is a level 5. And if you continue to go forward in time, if that same conditions last for another 12 hours, you keep adding to that, and your blowing snow gets to be category 8. So here's the land use map that we've looked at and reclassified. So everything in the red is open plains or open areas. You can see what type of land use types. And as we go into different land use we've given them a factor, a friction factor basically, and that will cut down on things. So when you get into the greens here in the east, there's a lot of the forest. If you were to zoom in real closely, there's a lot of speckly areas because even here in the northeast, you'll have some residential or commercial areas, and that'll be a little bit more open space as well. So this can show that the blowing snow will be a little bit more of an impact in the urban areas because you're in the urban areas. So here's the example again, the Central Plains, you got a 432. If we have the same conditions here in central Vermont, which falls into the high friction thing, we have just a 43 on our calculation for blowing snow, which is a blowing snow category of 1. And so this is how we try to normalize how blowing snow impacts change where you are in the country. The next component is ice accumulation, and there's already been work on that. It's the Sperry-Pilz index, which was developed in the late 90s. Now it's the Scaled Predictive Ice Storm Aftermath, because I think Sperry-Pilz ice accumulation is a trademarked deal or something. But anyway, there's offices in central and southern region that are creating these in GFE, putting these out on the web. There's an experimental product. So we just took what they did and the table, and then just multiply by 2 because the SPIA is on a 1 to 5, and we're doing 1 to 10. But this is how it works. You just figure out what the ice accumulation is and what your peak winds are, and depending on how those thresholds are met, you assign it a number. So we look at each of those components, and whatever is the highest wins and gets assigned for the final WSII. And right now we're playing around with 2 scales, a 1 through 10. So we calculated in a 1 through 10, and we're also doing a 5-color version of it. So I think the future of the Weather Service is more, the green, yellow, orange, red type of deal. But anyway, we can assign these into these categories. We may change the names. I know Rick is on the phone, or was earlier, and there could be some issues with calling it crippling. But the idea is there's different levels of potential impacts, and those impacts depend on how much preparation time you take or is needed. So we try to have a little bit of that. So for example, a minor category, there'd be some minor disruption to regular life, especially if you're not prepared. So, it's going to be snowing and a little slippery, so walk slowly on the sidewalk. Make sure you have snow tires on. If you don't have the snow tires on, you might slide off the road. But, when the storm is done, everything's shoveled away and, everything's back to normal pretty quick. That changes when you get to major and then the high level and the crippling, where recovery time may be on the order of days and weeks. So we're trying to get at that disruption component. So a couple of quick examples. This I just pulled off this morning. Here's the latest WSII. The way it works is 3 to 4, the minor, that's more or less into the advisory level of what we do now. 5 to 6 would be on the low end of a warning in our current lingo. So right now across the country, we've got some areas here in the Central Plains and out in the Southwest and up in northern New England. We're showing a minor level. And here's the watch warning map from an hour or 2 ago. And these are winter weather advisories, highlighted up there, and then some winter weather advisories, maybe some warnings up there in northern New England. And here in the Upper Peninsula, there's some warnings and advisories. Going back to the winter storm impact index, it lines up pretty close, though we're painting in a lot of green for the Upper Peninsula. I didn't look at the time frame. Maybe it's something farther in the future, but what we're saying is really from our perspective and based on the forecast, no big deal for up there, but there are some warnings. But, there is a fairly good relationship between watch and warning and our WSII. I want to hit a couple of examples from last winter. This was a storm in the deep south that when I think the Peachtree City office did their storm data write-up, they called it crippling nature of this winter storm was not because of the societal impacts. This was after the big traffic jam storm. but because of significant ice and snow accumulations and widespread power outages. So this, they're calling crippling. It was a big deal. And here's what our WSII had for leading up to that storm. So you can see lots of the purple, lots of 10s, 9s, and 10s. So we had a fairly widespread depiction of crippling across the southeast. Here is the other event from Georgia. This was the big traffic jam deal. What they actually say here, 1 to 3 inches in the area. But you know, there was all the confluence of all the issues going on that happened to cause the big problems in Atlanta. So from a storm data write-up, it was like, you know, it's not as much of a big deal from a meteorology sense. But here's what we had depicted, because there was some ice and snow, and again, down in the deep south, it doesn't take much to really tip our scale to the high end. But Atlanta is somewhere right on the fringe here. And so based on the forecast leading up to it, you go south of the city, and it would be much more of an impact to the north. It was not much of a big deal. So, you know, how does this relate to societal reaction and impact? You know, it's not always a one-to-one. So I had in here, you know, was it really a bad forecast? Did society act, you know, not what they should have? But in any event, we were still painting in through the WSII that, you know, there would be some significant disruptions to normal life in that region. Take yet another example from earlier late this fall, last month. Here was an event in the southern Appalachians. So there's the snowfall forecast, and it's what is it, 8 to 12, maybe some spots of 15 inches. You know, I have no idea if this is bad or good or whatever. I don't live down there, but you know, so what kind of impacts does that mean? Here's our WSII, and it was highlighting reds and even some purples in there. So major to, you know, locally crippling, I guess, event was being forecast in the southern Appalachians. So I think that stands out pretty easy on the map. You just look for the red and purple, and you know, your eyes are drawn to it. Here's what I think the Morristown office had. This they threw on Facebook. I think I got it from Facebook or their webpage. So here's what they were communicating, which, you know, is to me is a bit hard to kind of read through, and it's, you know, it's a lot more than just a simple map of, hey, it's going to be major to crippling. But I see terms in here: life-threatening winter storm, you know, impacts. There's going to be downed trees and power outages. You know, highly discouraging any travel or hiking or camping into it. Life-threatening travel conditions. So they were looking at it and really going, hitting this hard, saying this is really a threat to the area. So, you know, I think our WSII showed very much the same thing through our algorithm. I'll pick on another example. This is sometime last winter in the Great Lakes area. So some minor lake effect, I think, was going on. The Grand Rapids office, we've been working with them as well on some of these concepts, and so they are creating a similar sort of deal where it's an impact-based graphic. They're doing it a little more manual in nature, but they were again highlighting very similarly that there will be a minor actions are going to be needed, minor event for the western side of Michigan. So going back to the WSII. Very similar depiction. You know, we were both in the ballpark of saying the same sort of thing there. Last winter, we tried to start to do some verification. So we had some help from Caribou, Grand Rapids, and St. Louis, where basically they would look out the window or read the reports from what happened and assign the storm a number 1 to 10, and then look at what the WSII had for that, and we could do a comparison on that. So it's a very subjective verification, but I think all of us, we know what is a Category 10 winter storm versus a Category 2. And since the WSII is really built in a subjective nature, you know, it is a little bit of a comparison and doing the verification in that way. Anyway, this was just to see if we were in the ballpark. So in this case, the WSII forecast, so the number of times that we forecast a certain level, 1 through 10, and then the number of times that we had the verification in that category. It lined up fairly well, pretty strong correlation, and when you overlay the two, there was a little bit of a bias. We were a little bit on the higher side, but not by too much. So it showed that we seem to be in the ballpark. So for this winter, we've trying to do things more formally. We've got a few offices in the Eastern region and scattered across the rest of the country too that are willing to help, and we've got a little verification submission form, and they can fill out some key information in on it, and we're going to use that and the information we get back to help go back, and we can look at how we're doing our individual components and how do we want to put it all together and hopefully do something for next winter. But all of this information is also going to help us answer some of these questions. The first question is, just because we can, should we? That is something that I think is always an important question to ask of any project when you're doing it. And if we do this as an agency, what does it all mean? Who is it for? Is it for us? Is it for the public? How do we do it all? There's a lot more questions, but we want to be able to have the information to kind of move on and see what comes of that. So I threw a lot of stuff out at you. I apologize for going a bit long, but that's the WSII in about as short of a time as I can get it to you. So any questions, comments? I am listening. Yeah, well, right now, 2 inches, anything over 2 inches per hour is the highest you can go. And the thing that we have to be careful of is we're taking 6-hour chunks of time. So, instantaneously or within that 6-hour block, there's going to be higher rates. So, I think in reality, when you have a 3 or 4 inch an hour event, even up here, that's let's just shut the door on that. But for us to forecast 3 inches per hour for an entire 6 hours, we don't do that. We can't, and the reality is it doesn't happen that way. It may be an inch, half an inch, an inch, 3 inches, and then half an inch. So you end up over that 6-hour period, probably closer to a 2 inches an average, 2 inches an hour average. Yeah. So that comes into play too. It's we can only work with what we have in the NDFD, and there's certain weaknesses in that data set. But yeah, at some point the snowfall rate tops the chart. Whether it's 2 inches per hour or we need to change that to 3 inches or 1.5 inches, that's what some of that feedback that we're looking for to help gauge how did our index go and work, and does it seem to match reality to some aspect? Absolutely, yeah. If we could have hourly data, it'd be great. No, is everyone still digesting it all? It's a lot to take in.
Hey, Andy, this is Matt in Rapid City. I was just curious if you've heard of something similar used by the media, because just last weekend our local ABC station talked about this winter impact index that they were using, and so I contacted him, and he said it's part of this national initiative, so it looks like there's some similarities. Do you know anything about anything else outside of what you're doing?
I don't. Now, I did Google, winter storm impact thing, and it looks like the Weather Channel has something like their StormCon deal. So there is some thing on their website that has aspects to it. I haven't gone and talked to Tom Niziol or anything. And I know some TV stations here in the Northeast. They're doing some maps. One station's trying to do like their power outage index or whatever. But I think that's freehand. So I don't know. Are they an AccuWeather station? I don't know if AccuWeather's doing anything behind the scenes. I just don't know.
I'm not sure. I'll have to check with him.
Okay. Well, if you get any information, if you could pass it on, just so I'm aware. Just good to know what's out there.
Okay, will do.
Thanks.
Andy, this is Rich. How you doing?
Doing all right.
You mentioned the subcomponents that different precipitation types or different hazards compute into the overall index. Are you looking at any way of breaking that down into subcomponents for the emergency managers and people making decisions?
Yeah, I think if in a perfect world, I guess, or an end state is probably a better way, the WSII would have to be, I think you'd have to display the subcomponents. And when we are producing it, and we put them up on the web page, and I guess if I minimize this and go, oops, you know what, let me, while I'm talking here, we are, hold on, I can't talk and talk and type at the same time. We are doing some of the subcomponents, but ultimately for I think, see if I got the password right, for an end use, you'd have to show the subcomponents so that the emergency managers can make those better decisions. So it would be a multi, probably a couple of layers in there. So you'd first look at, the overall big picture and go, oh, I'm in the yellow. Let me click on that and drill down, and then that would open up another page or another something to show, the subcomponents. So on our web page, we do have some of those subcomponents. We're not including snow load right now, but looking at that, if we did, it looks like you've got some wet snow that you're forecasting for part of your CWA. I see some pixels of yellows and oranges up there. And so that, I think, would be a delivery mechanism. You'd have to have, multiple ways of getting at the data to really digest it. Did that answer the question?
It did indeed.
We are running this every hour and uploading it to the website every hour. So so every hour we're downloading NDFD data, doing a bunch of things, and so those maps that we do that officers are using for DSS and social media, we're doing that every hour, and then the WSII is recalculated every hour as part of that. So from most hour, from 1 hour to the next, it usually doesn't change much. It's when there's the forecast updates that you see the biggest changes. Or we cross that 0 or 12Z threshold and we're looking 6 hours farther down the road. There could be some changes. Well, I would, if the determination was that there's, this is something good and useful for the agency, it would have to be generated centrally. You can in theory run this off of model data. If you get all the model data, do those same calculations, you can create a WSII based upon the GFS. It's just an output. So then you can ensemble the WSII. You can do all sorts of crazy stuff. So same thing with the WPC. If they had all the inputs, if they've got the QPF and the SLR and the WINS and all that, they could generate a WSII internally based upon their data for use in discussions. It's just a computer algorithm, so that can be done. The questions really we have to figure out from an agency is there some place for this, and if there is a place for it, where is it and how does it work? So. Right, and because that's just based strictly on county-based, zone-based, one number thresholds, and that gets back at my point of, 1 inch, 6 inch, a 6 inch snowstorm one time is not the same as the next 6 inch snowstorm, yet our warning criteria is 6 inches or 4 or whatever it is for your local office. So, it is what it is, that watch collaborator. But there's more to it than just a total amount of snow.
Hey, Rick, this is Steve Zubrick. As a former acting deputy director there, I hear you on that, and I think this was a response to kind of a senior weather service management directive to implement this year. But I think there's a lot more that could be done with it, like you point out, like Andy has pointed out in here too, and like here, our journeyman here was pointing out that maybe road temperature is actually something that needs to be factored into it, and I know Western Region has been doing some work with that, and even I think WPC or EMC actually has a product that has some road conditions in it, so. It's that collaborator was just kind of like a baby step, if you will. And
you have to try and experiment because sometimes the experiments don't work out as well as you hope. I think this is a good experiment. The one WPC was a good idea, but it's pretty limited in its scope. So.
But you need to tell them that. You need to give them that feedback. Definitely.
Andy, Brian here at Western Region. I have 20 questions for you, but I'll only ask one right now. When you look at the verification, what I was thinking is, as part of possibly doing impacts, we need to rethink the way we do verification as well. And what I mean by that is, to me, it doesn't matter if you look out the window and it verifies, meaning you think there were 12 inches of snow on the ground and you had a 10 out there. What matters is if somebody is actually going to do something about it. And if we are going to go down this road of ESS and impacts, if nobody is actually changing their mode of operations, then the utility doesn't get any higher. What do you think about that?
Well, I mean, from I think everyone's in the Weather Service's perspective, that's when we issue a warning that we're hoping people change their, what they're doing. But some of the issues are people don't understand what a warning is. But yeah, there is that component. I think that falls under the whole Weather Ready Nation, the Weather Ready Nation ambassador, getting, every component of the weather enterprise involved in this, really a national cultural change, where it's up to us to better depict, hey, there's going to be something really bad. If you don't change your normal behavior, you're going to have problems. And there still may be problems afterwards. We're not going to be able to control everything. But I look at some of this in the aviation world. AWC will issue a SIGMET for, let's say, turbulence. In other words, here, this airspace, it's off limits because we think there's going to be turbulence. Well, the air traffic controllers keep planes from flying in there, and nobody runs into turbulence. And that's what we need. Everything to really work that way. And that's a big change from how things work right now and how society reacts. I don't think we'll ever get there, but that I think is part of the whole piece.
Okay, but that's a good example. I mean, that's my point exactly. In that case, people are taking action as a result of forecasted impact. So
Right, and
you're right. They've ingrained that in the culture, and they can do that. Whether it's possible in other cases, I don't know. But that would be the only way that you have utility out of going down the route of impact and index.
right, and it's going to take everyone to work together to change everyone's behavior, for at least the decision makers. So, let's say that we do our forecast and the WSII shows for central Massachusetts it's going to be an 8. Well, the public works people or the folks that handle the Mass Pike need to have something that goes, oh, I have an 8 on the WSII. That means I need to start doing this, this, and this. That's to get to that point, it's a long way down the road because there's so many other moving parts. It's not as simple as just planes and the air traffic control system. That's a very simple transportation system, very controlled. The public at large, it's the Wild West.
So, Andy, this is Rich again. As far as, have you given thought to, as this experiment matures, is using the index for winter storm watch warning decisions where, right now we have a lot of subjectivity in terms of, trying to estimate the impacts that go in, based on time of year and all the things that we've done and, first storm, last storm, prior storms, that you could use this index to help in terms of the consistency of watches and warnings across service areas?
Yeah, it could be used that way. And again, on my last slide, that was one of the questions. What is this all for? Is it external, internal? But we could do something like that. Right now we're only running on the published official data that's out there, and so you're too late to make that decision on whether I need to issue a watch or a warning or whatever. But the concept could be applied to the data that you're working on, certainly.
I would go one step further. If we're at a point where we were publicly using this, that we were talking about here's an 8, an impact storm of an 8, what do you need a warning for? You're already communicating it probably better than quote-unquote winter storm warning is now. So I would proceed the whole approach if this was the direction that we went.
I'm all for that, Jeff, and this is a slide that I have as like extras, but the hazard simplification project, I think, is exactly that. It is all that headquarters is looking at. It's really about getting rid of the words watch, warning, and advisory and conveying the threats or the potential impact, the risks, using colors and or numbers. And what they're doing in Europe is I think what they're looking at, the meteor alarm. You see something highlighted in yellow, and you click on it, and it's a yellow alert for whatever. I think that's where we need to go, and I think that makes much more sense and will be much more understood by the public than what we currently do.
And you've been coordinating your efforts with Eli Jackson folks at Webster Tech.
Yeah, I've been in touch with them, so they know what we're doing, and there's other projects of this nature around the country, and they're trying to keep their pulse on everything and just see what what comes of that, and how do we want to go as an agency. That's what they're trying to figure out.